introduce our next guest. It is Francis Su. Francis is the Benedictine Carver Professor of Mathematics at Harvard College. He's also past president of Mathematical Association of America. Like everyone here, he's passionate about popularizing the joy and wonder of mathematics. And he's working on a book. I just love the title. It's called Mathematics for Human Flourishing. Just love that. Can't wait for it to come out. It's due out next year. Please welcome Francis Su. Francis Su.
Thanks a lot. Thank you very much for having me. I'm really pleased to be here. When James asked me to give a talk, I wasn't sure what I would talk about, but I decided, as you heard, that I'm writing a book. The book is about connecting the deeply human themes that drive us to do mathematics. It's about the deeply human themes that drive us to do math. Since exploding dots is really a quest for meaning, I thought it'd be good to maybe share with you some of my thoughts about meaning in mathematics. I'm going to start off with a couple of quotes and a story. It is the unique power of human beings to invest our creations with meaning, to interpret the world rather than blunder through it. My friend Andy Crouch. And a quote from Winston Churchill talking about his experience with an influential teacher. My teacher convinced me that mathematics was not a hopeless bog of nonsense, and that there were meanings and rhythms behind the comical hieroglyphics, and that I was not incapable of catching glimpses of some of these. I was skeptical when my dad hired a car to drive our family from the airport to the remote village in China where he was born. This dilapidated clunker didn't look like it would fit the driver and the 5 of us, plus all of our luggage. And I grew more skeptical as the 2-hour journey wound its way along bumpy dirt paths populated only by goats. Was this a shortcut? Were there really no paved roads to this village? And then as we drove over a particularly uneven path, the car rolled over a bump, got wedged against it, and wouldn't budge. The front and back tires spun helplessly against the soft dirt. Now, of course, I don't have a picture of that event, but I found something like it online. And actually, if you search for car stuck on a bump, you'll also find this example where President Obama got stuck at the Irish Embassy in 2011. So we were stuck. And for us, this wasn't looking good. We were isolated miles from any real civilization on a path that was unlikely to receive any traffic. The day was fading fast, and we could not walk dozens of miles before nightfall. Now, our predicament didn't seem like a math problem. It had no numbers, no symbols, no formulas, but I couldn't help but feel that my mathematical training might save us. I recall having seen something like this problem before in a Martin Gardner book about a truck stuck beneath an overpass, unable to back up due to traffic, but too tall to proceed forward. And the puzzle asked what to do. And I remember the answer. Any of you know? Yes, let some air out of the tires. This would lower the truck enough to roll under the overpass. Now that puzzle seemed somehow similar to our current predicament, yet somehow different. We were not stuck under a pass over us, but over a bump under us. Perhaps we could inflate the tires. Yes, what a great idea. But we didn't have a pump. No pump. So what should we do? How was math going to save us? Now, there's a moment in problem solving as you start to brainstorm and think of potential strategies when you must make sense of the problem as it really is. When you must strip away all the non-essential elements so you can classify this problem and make connections between it and the catalog of problems that you've solved in the past. And the same thing happens when you encounter a new idea in mathematics. There's a moment when you have to place it in conversation with the things you already know. No new idea can survive in isolation, or it will die. And to place an idea in conversation with other ideas, you must really wrestle with its meaning. The quest for meaning is a fundamental human pursuit. Augustine of Hippo spoke about meaning as a relationship between signs and the things they signify. Thus, when you want to know the meaning of something, you are always asking about its relationship to other things. For instance, if you ask, what is the meaning of life? You are really asking, what is my place in this world in relation to other people or the things in my life? Or if you witness a strange event and ask, what does it mean? You have made a choice not to view the event in isolation. You're asking what its implication is for other things. And if you look up the meaning of a word, you'll get a definition. And that definition places this word in relation to other words or ideas. The poet Jorge Luis Borges said, "Every word is a dead metaphor." And by this, he meant that words do not exist in isolation. Every word has a meaning that comes from a certain history, a context out of which that word originates. So, for instance, the word calculus used to mean Latin. Anybody know? Small stone, used for counting, like the kind that you would find in an abacus to do arithmetic, or in an exploding dot machine. But today, the word calculus refers to a much more complicated kind of addition. The word geometry used to mean land measurement, right? But today it refers to mathematical insights that could be used for land measurement. So you see, each word carries with it a metaphor, an ancient but ongoing conversation. Words don't exist in isolation. And neither do mathematical ideas. If you think about the number 7, to say anything interesting about this number, you have to place it in conversation with other things, right? To say 7 is prime is to talk about its relationship with its factors. To say 7 is 111 in binary is for it to have a dialogue with the number 2. To say 7 is the number of days in a week is to make it converse with a calendar. Right? The number 7 is both an abstract idea as well as its concrete metaphors. A prime, a binary number, days in a week, or a collection of exploding dots. Thus, every mathematical object is a metaphor. That sentence was a metaphor as well. Every object's meaning takes shape and even grows from the metaphors that represent it. For example, while the Pythagorean theorem is a truth, it is also metaphorically the understandings that help you see why it's true or why it's useful. So the theorem grows in meaning for you each time you see a new proof or see it used in a new way. Or just as we saw in the last talk, a number grows in meaning when you see it as a collection of exploding dots. Right? The meaning of a mathematical idea is found in its relationship with other ideas. No idea can survive in isolation, or it will die. The mathematician Henri Poincaré said, "Science is built up with facts as a house is with stones, but a collection of facts is no more a science than a heap of stones is a house." Without meaning, mathematics is just a bunch of isolated facts, a heap of stones, as Poincaré says. And no student, none of us, want to build a heap of stones. We'd rather build a house. We'd rather build a house. That's why memorizing times tables is boring. That's a heap of stones. But look for patterns in multiplication and understanding why they happen. That's a house. And in my own experience, the most important things I learned in mathematics were not the facts themselves, but the meanings we attach to those facts. And to teach or to learn or to communicate mathematics well, we have to wrestle with meaning. The quest for meaning in mathematics also builds several important virtues. Here's one virtue: story building. Mankind has used stories over centuries to convey history or essential truths, and a story connects listeners to itself and to each other. Stories create create a narrative out of disparate events. And it's no different with mathematics. Teach or learn a bunch of separate mathematical facts and it's just a heap of stones. To build a house, you have to set those stones in a framework. You have to set concepts in context to grasp their significance and meaning. And those who seek meaning in mathematical ideas become natural story builders and storytellers. That's what we want to become. I remember being really puzzled in an advanced math course when I learned a certain concept called compactness, because I was given the definition and asked to do exercises with it, but I wasn't told its significance. It was a statement without meaning. Not until someone said to me, being compact is the next best thing to being finite. Did I have a story, a way of organizing the idea in my head so that I know where this stone fits in the house that's being built? And there were many other instances in my math education where a story captured by a pithy phrase helped me see the big picture. Here are a few. In calculus, someone once told me, integration by parts is the inverse of the product rule. And suddenly, both concepts became clearer. In statistics, I heard this story. Learning statistics is learning to be a good detective with data. And in all of mathematics, there is this lesson which one learns over and over again. Objects in math are not as important as the functions between those objects. And this maxim recapitulates what I am saying about meaning, that objects don't have meaning without considering their relationship to other objects. Functions are relationships. Functions tell a story. So in a delightful, self-referential way, this maxim is a story about telling a story. Now, there are many ways to build a story, and if you're a teacher, you want to teach students to build a story. You want to build a story for your students. So you could, for instance, explain where a stone fits into a house, as in my earlier examples. This is an organizational story. Or you could build a historical story, harnessing the flow of history to motivate the ideas of mathematics. Or you could build a pictorial story, right? Every proof without words is a pictorial story. Here's a proof without words of the Pythagorean theorem. Or you could build an experiential story through hands-on learning or inquiry-based learning. And here, the story you build is by giving people experiences that help them process what they're learning effectively and apply their new knowledge. So, for instance, when I give a lecture, I'm careful to map out the arc of the lecture as some kind of story, with an introduction, a motivation, a point of tension, a climax, and a resolution. I worry less about cramming in all the possible details than about telling a good story. Because I know if my students are inspired, they'll read more on their own. And to give students a chance to build and synthesize their own stories, I assign writing in my courses. I encourage presentations where appropriate. And I coach them in their mathematical communication. And is story building a skill useful in thinking effectively in other areas of life? Yes. Right? And as teachers of math, we should claim this skill as one of the ways that we equip our students. Right? Wouldn't it be great if employers began to get the sense that hiring a math student meant that they were also hiring an effective storyteller who could deeply engage the meaning of an idea and place it in context? A second virtue that a quest for meaning builds is thinking abstractly. It may seem strange to say that, since people often think of abstraction as stripping away meaning. But in fact, abstraction does the opposite. It enriches meaning. When you see the connection between one thing and another, perhaps you observe they have similar structures or similar behavior, then those similarities create a connection, a new meaning that wasn't there before. And Poincaré famously said, mathematics is the art of giving the same name to different things. Actually, another writer responded to this and said, and poetry is the art of giving different names to the same thing. The art of giving the same name to different things. It's like with dogs, right? If you've only ever seen one dog, you might think a dog must be a German Shepherd. But once you've seen several dogs, you begin to realize the meaning of dog is richer than you realized. Right? Abstraction enriches meaning by helping you take a collection of perspectives and see just what is essential about dogness. Abstraction helps you see what's the same about many different things. And this is one of the main reasons to teach kids algebra, right? Beyond teaching basic skills in algebra, those skills shouldn't eclipse its bigger value to help students see what's the same about many different things. Yes, the quadratic formula is a formula, but it's also a powerful lens, a defocusing lens that makes many different problems look the same. Most dramatically in physics, the quadratic formula makes all problems about trajectories of objects under gravity look the same. Yes, we should teach kids to be fluent in manipulating algebraic symbols, but we should also constantly remind them that as we do, that abstraction is also about helping them be flexible thinkers, a skill so necessary in almost any profession. The skill of deriving a formula that works flexibly in many situations will translate into the skill of writing a flexible computer program that can handle any input, or designing a building that works for many different people. And the skill of abstraction pays dividends, not just in careers, but in other areas of our life. Don't we often strip away extraneous details of a personal problem and look for its essential nature? Don't we look at problems from multiple points of view? Aren't we better equipped to do this because of mathematics? So when I hear the puzzle about the truck going under an overpass, I don't dwell on extraneous details like the fact that it's a truck or how much it weighs. I strip away all the details and I attempt to see that puzzle from many different perspectives. And this can help me so that when I encounter a problem like it again, I can recognize a car and a bump on the road as essentially the same beautiful problem. And a third virtue that a quest for meaning produces is persistence, right? Discerning the meaning of an idea, it takes patience. It takes reflection. It takes hard work. And guess what? When you go through that process, you're rewarded with something. You're rewarded with joy, right? How can we help our students see these larger goals that mathematics builds in people? And with practice and accumulated joy from successful quests for meaning, we cultivate persistence for this work. So at the heart of a proper practice of mathematics is a quest for meaning. You can't flourish in mathematics or in life without finding meaning in what you're doing. And I like this description of mathematics, popularized by Keith. Mathematics is the science of patterns. But I'd like to add to it an active verb, because math isn't static. It's something you do to create relationships between patterns, to give them meaning. So I prefer to say mathematics is the science of patterns and the art of engaging meaningfully with those patterns. Now, our car was still stuck on that bump. And while the others fretted, I wrestled patiently with the problem because my mathematical persistence, fortified by past struggle with meaning, kept me from giving up. My mathematical story building had placed the puzzle of our predicament in the category of the puzzle about the truck stuck under the overpass. And my mathematical penchant for abstraction had stripped our puzzle down to its bare essentials, an elegant problem that appears to be about the relationship between a vehicle and a bump, but is really about the relationship between a vehicle and its tires. How then should I think about our vehicle and its tires if I want to raise the car, but I had no pump to inflate the tires? Could we raise the car while leaving the tires in place? And that's when the insight came. Everyone, I said excitedly, get out of the car! And get all the suitcases out of the car as well. And after being freed of 5 people and luggage, that's about 700 pounds, the cab of the car lifted. It was no longer wedged against the bump. We were free. Yeah, it deserves a round of applause. So my main message is this. We become better teachers and learners and communicators of mathematics by embracing meaning. We develop into joyful story builders and abstract thinkers, freed from our baggage, who can help others catch glimpses of underlying meanings and rhythms of math. Without meaning, math appears to be a hopeless bog of nonsense, comical hieroglyphs. But by investing mathematics with meaning, we can gracefully interpret the world and solve the problems of our world rather than blunder through it. Thank you very much.
Thank you, Francis.